Welcome to Coach Actor's Math. Today we will be talking about segments, midpoints, and bisectors. A midpoint, just a reminder, is a point on a segment that is equidistant from both endpoints. We've always denoted that by saying I've got a segment ST, and I'm going to have a midpoint M, and I go ahead and mark those two segments SM and MT congruent to show that M is directly in the middle of S and T. Example 1, B is the midpoint of AC. If AB is Z plus 2 and BC is 2Z minus 6, what is Z? So really what you got to come down to is AB and BC are congruent. So in this case, I can say that Z plus 2 equals 2Z minus 6. So in this case, that would mean that Z would equal 8. So, looking down a little further, we talk about segment bisectors. A segment bisector could be a point, a line, or a plane that intersects a segment at its midpoint. So, we've already been talking about ST and M as the midpoint. That would be a segment bisector. To make things a little more interesting now, I could make this line MO, and line MO would also be considered a segment bisector. By calling it a segment bisector instead of a midpoint, it allows me to use anything else, whether it be a point, a line, a segment, a ray, multiple things to bisect that single segment. So let's look at example 2. If B is between A and C, and AB is 2y plus 6, and BC is y plus 8, and AC is 20, find the value of y and determine if it is a bisector. So again, I've got to sketch myself a picture. I'm going to make it look like B is a bisector for now. I'm going to say that 2y plus 6 is AB, and y plus 8 is BC, and I know the entire piece is 20. Which brings me back to my rule that we learned earlier, that part plus part equals whole. Or in this case, 2y plus 6 plus y plus 8 equals 20. Or 3y plus 14 equals 20. 3y equals 6, or y equals 2. Go ahead and plug that back in, and I would say that AB equals 10, and I would say that BC equals 10. Remember, no line above means the distance between. So because AB and BC are equal amounts, and B is between A and C, B is a bisector. So, looking down a little further, using the same thought process, we're going to now talk about it and say that segment WY bisects line UV, or excuse me, segment UV at Y. In example 3, if UY is 5, then find the rest, the other possible pieces. I'm going to go ahead and redraw this for our benefit and say that UI is 5. That means that YV must also be 5, and the whole thing would be 10 because Y is a bisector, which means it is in the middle. So they ask us to find YV, which is 5, and they ask us to find UV, which is 5. And again, it is very important that we label units, and if they don't give us any, we're just going to say 5 units. My challenge to you is to go ahead and try examples 4 and 5 on your own. Give you just a moment. Please pause the video. All right, welcome back. Example 4. Same idea. Let me redraw our line real quick. We've got u, we've got v, we've got y. Notice I draw the line every time. If I draw it, you should draw it. 4x minus 3 and x. And we want to know if uy and uv, we want to find the answer there. So we know right now that they are bisector, or that y is a bisector. So I'm going to say 4x minus 3 equals x. Well, in that case, 3x equals 3. So x would be 1. So uy would be 4 minus 3, which is 1. And yv would also be 1, which means that uv would have to be 2. Again, noting that all of these are in units. Example 5. Got a segment uv, we've got a bisector y, and we know that uv, notice it's very important that you're looking at what piece they're telling you, is 18, and uy is 9. It asks me to find yv. Well, it shouldn't be that hard to find yv. You should have been able to find it with either piece of information. They should have been able to leave this 9 off and ask you to find it there, divided by 2. Or they should have been able to leave the 18 off and had you recognize that yv is the other half of that segment. It would be 9 units. So, looking down, I'm going to try this one more time. But this time I want you to see if you can do examples 6 and 7 on your own before I even start them. So please go ahead and pause the video, take a minute to try those on your own. Welcome back. So looking at example 6, we're going to say that wy still bisects uv. So I'm going to draw a picture of uv with y as a bisector. We're going to say that uv is x plus 6 and uy, that's why you got to be careful. uv, the whole piece, is x plus 6, and this piece right here is not x plus 6 but x minus 1. So we've got to find yv. Well, in this case I know if y is x minus 1, yv must also be x minus 1. And again, I'm back to a point where I can use our segment addition postulate. Part plus part equals whole. In my case, I'm going to say 2x minus 2 equals x plus 6, which is the same as me saying 2x equals 8 or x equals 4. So to find the distance from y to v, I would say 4 minus 1, which would tell me 3 units. And that would be my distance right there. So looking at number 7. Still got uv with y in the middle. Still know that it's a bisector. They tell me that uy is 3x minus 6, and they tell me that yv is x plus 2. And they ask me to find uv. Well, the first step is to find x. Well, we know that these two pieces are congruent, which means that the distances are also equal to each other. So 3x minus 6 equals x plus 2. Go ahead and solve for x. X equals 4, so go ahead and plug that back in. Each of those pieces should be 6, which means that my distance from u to v would be not 6, but 6 plus 6, which is 12 units. thank you again for watching Coach Teichner's Math. Have a great day, and look forward to seeing you soon.